So thanks for sticking around, everybody, by the way. I realize it's towards the end of a couple of intense days. I am, as Kurt said, I'm Damian Brady. I work as a cloud developer advocate for Microsoft, which means I don't do real work anymore. I do things like this, which is fantastic. And I'm talking to you today about DevOps for data science, and that encompasses things like machine learning and all that kind of stuff, which I realize there's DevOps, there's data science, there's machine learning. I don't have blockchain in the title, but I understand if, like, to some extent, maximum buzzword, right? I promise not to do that. What I'm going to talk about is really this crossroads between these two kind of areas, DevOps and data science. So DevOps is something I've been doing for a while. Data science is pretty new to me, but something that I got interested in mainly when I joined Microsoft. I was interested in it when I was at university, and then I figured out that there's a lot of maths, and I wasn't very good at maths, so I kind of abandoned it like any good software developer would do because it was too hard. But lately I've started to get back into this idea of what it means to overlap these two, and I'll talk a little bit more about what I'm talking about. So like I said, DevOps is something that I've been doing for a while. I feel like I know what I'm talking about when it comes to DevOps. I'm a member of a team at Microsoft nicknamed the League of Extraordinary Cloud Developer Advocates, or DevOps Advocates, which rolls off the tongue. So I do that. I'm on podcasts occasionally. I have my own video show on Microsoft's video site called Channel 9 called the DevOps Lab. I contribute to DevOps interviews and stuff like that. So I feel like I know a little bit what I'm talking about when it comes to DevOps. Data science, though, not so much, right? If you put me on a scale of how much I know between nah to yeah, I'm I'm starting to get the idea, but I'm not really there. I haven't really done it in anger a lot. I haven't done a lot of machine learning things. I'm getting my head around how it works. But thankfully, working for someone like Microsoft gives me the opportunity to talk to a lot of smart people who fall very firmly into the yeah column of understanding what they're talking about. So people not just inside Microsoft, but outside Microsoft. I get the opportunity to talk to a lot of them and find out what they actually do day to day. So blending these two and finding out where this overlap is, and more specifically, what these DevOps techniques and practices and understandings that we have can bring to a data science community. That's really what I want to focus on today. So let's start with DevOps. And you might have seen this definition from Anthony Borton when he was up here before. I didn't actually watch his talk, but I assume he said this. This is kind of Microsoft's definition of what DevOps is. The union of people, process, and products to enable continuous delivery of value to your end users, right? There's a few parts to this. He might have gone through it, but the general idea here is that we're trying to deliver value to your end users. Introducing bugs is not value, so going really, really fast is not necessarily all you need to do. Automation's part of it. Monitoring is really important. There's this life cycle of stuff that you do, and that's how we think about it sometimes, right? You plan and you track your work and you make sure you're doing the right things. Then you write the code, or you make changes to infrastructure, or you implement infrastructure as code and make sure that all of that stuff is stable. You build the stuff, you release it, you run through your tests, you make sure it's okay, you put it in production, you monitor what's happening in production, and you learn from that, and then that feeds back into your planning and tracking, right? Everybody's pretty down with that, I would imagine, by this stage in the conference. And everybody here has some exposure to DevOps, I would assume. So this is pretty familiar, right? We have this cycle, we know this stuff, we've done it for a while. What about data science, though? And I tried to look for a really concise definition that I liked as much as the one that Microsoft has. And the best definition I could come up with was a bit of a wall of text, or the best one I found was a bit of a wall of text. It says it's a broad field, refers to the collective processes, theories, concepts, tools, and technologies that enable the review, analysis, and extraction of valuable knowledge and information from raw data. There's a lot in that, right? In short, I think the summary of the summary is that you're using data to get knowledge out, right? And the focus of this, no matter what your data science project is here's stuff that we want to find out. We want an answer to this question. Let's get the data together, filter it, process it, do it in some kind of way that can tell us the answer to that question that we care about. And this is a thing we talk about in machine learning a lot as well. People will quite often say, well, we've gathered all this log data, and we've got the transactions that people processing and we've got the products that people are buying. Let's just run some machine learning over it and then it can tell us some things, right? It's not really how it works. Machine learning has to start with what we call a sharp question. In other words, what do I want to know from this? And how do I do stuff better is not a sharp question, right? Things like with image recognition, for example, what is this object? Or what category does this transaction belong to? Or I am running a credit card company. Is this transaction that somebody just made, is that an unusual transaction? These kinds of things are sharp questions. You need something that you specifically need to ask to get the answer out of with machine learning. And data science is a broader kind of picture of that as well. So machine learning uses certain techniques to get these answers out. Data science as a whole may use anything from just running a SQL query and generating a report to hand to your manager once a year. That can be a data science project. It doesn't need to have these deep neural networks and things like that. But the process of gathering that data, analyzing it, filtering it, processing it, and then getting an answer out is really what data science is all about. So if we think about that cycle we had for DevOps, right, and try to apply that to data science, it's not too far off, right? The first step is really to acquire not just the data and understand the data, but acquire and understand what we're trying to do with that data. What is the question we're trying to answer? We need to prepare that data because your data is never in a format that you want it to be in. If anybody has ever worked with data where you're trying to get knowledge out of that data before and you're expecting things like your temperature column to be a nice, consistent temperature. There's a few of them that are 3 digits because somebody made a typo. There's one of them that says warmish because we left it as a string because that seemed sensible at the time. All of this kind of stuff, you need to do a lot of preparation of that data to be able to get the stuff out. And then you use that data in its prepared fashion to generate some kind of model that describes what that data is telling you. And the idea is, in a lot of data science projects, is to have a predictive model at the end of that. So we've gathered some patterns, we've got a model of what this data looks like, and now we can feed new data into it and it can predict what's happening. So we have this predictive model. And then we deploy it out to production, we evaluate how well it's doing in production, ideally, and then maybe that can help us acquire new data or understand the data a little bit better. So we still have this cycle, right, which is really interesting. The line in the middle is something that we don't really think about with software development, but it's something that we actually do, right? We'll write some code, have a look at it, go, that's not quite right, do a little bit of a refactor, or I got that calculation wrong, we'll change that. So we have this, what we call an inner loop of the work that we do. I make some changes, I run it, that's not actually calculating correctly. I've put a less than rather than a greater than for the 400th time in my career, right? So we have this inner loop of relearning or re-understanding what we're trying to do until we get to a point where we can deploy it and evaluate it. The same thing happens with data science. It's just that a lot of the time, it's not quite as formal as what we sometimes do in software development. A lot of this inner loop is a data scientist playing with data on their machine or on a massive VM in a data center somewhere to try and understand what that data looks like. So by applying some DevOps practices to not just all of this process of getting a model out, deploying it to production, and then looping through so you get more and more idea of what's going on, but also that inner loop, what we were talking about. How do you actually do your experiments, learn from them, and then continually do that work? DevOps practices can definitely apply to stuff in data science. So there are formal data science processes. So I'm not saying that data scientists all sit there and just hack away at data and then say, here's a model, or here's your answers, right? There are some formal data science processes. KDD, CRISP-DM, there's a cookie-cutter data science template, team data science process. Choosing one of these not at all at random, because it's the one that Microsoft recommends, is team science data process. And it more or less goes like this. You understand the business question, you try to understand what the data is supposed to tell you. You acquire any data that's missing, you acquire it from different sources, you understand that data, and then you prepare it ready for modeling. You create these models, you deploy those models in a way that makes sense, and a deployment could literally be a Word document you send to your manager, or it could be a predictive TensorFlow model that you deploy out in a Docker container to production. And then your customer accepts it because everything's fine, and you finish the project, right? This is a little waterfall-y for me, and I think it's a little waterfall-y for most data science processes as well. But this is something that Microsoft actually uses when they go to engagements at companies. They do use this process. And it's relatively formal. There's definitely things that are done in a particular way, and documents that are produced and results that come out. It works, like it does a decent job, but it doesn't apply a lot of the practices that we've learned in software development to make a better process and deliver value to your end users as much. So, what can we do from a DevOps perspective to help with this process? To apply some of the learnings that we have learnt throughout all of our software development careers to get to this point where DevOps is the new buzzword, that everybody is doing things this way. How can we apply that kind of knowledge to some stuff that happens in the data science world? Very quickly, the other question is, why do we need to apply this stuff to the data science world? Is there anything wrong with that process they're using? And maybe not. Like, maybe if the results, or if the data science project is to develop a Word document once a year to tell the business what types of products they should be selling more of, like, do you really need a long, drawn-out process with continuous iterations to get that document out every time? Well, maybe you don't. Maybe it's fine for a data scientist to sit there and go through the data and come out with a document at the end of the year and say, there you go. Like, maybe that's okay. However, data science, and especially things like machine learning, algorithms, and artificial intelligence, are increasingly becoming a part of the software that we write. Right? We talk at Microsoft about the commoditization of AI. So AI used to be this thing that was really difficult to get into any applications. Like, you need dedicated mathematicians and statisticians and data scientists and people to do any of that stuff. You imagine doing a handwriting recognition 30 years ago, right? It was a difficult thing to do, right? Now, you call an API, somebody else has done that for you. There's transfer learning from machine learning techniques as well, where if I want to identify faces in a photo, I don't need to go right from scratch and train a deep learning algorithm to understand what a face looks like and then be able to identify people from each other. No, you can use a face API and just say, these are the 6 photos of the person I want you to identify, and that transferred learning just is now your custom model that you can use in your application. So we are using this stuff more and more in the applications that we write day to day. So I think this is really important. Applying the techniques that we've learned in software development to data science, which is becoming more popular, used in software development, I think it's really important to get in sync and share those learnings. All right, a few things to care about when we're doing this as well, because we're all software developers, DevOps engineers, operations people, I would assume. So we need to care about a few things when we tell the data scientists, this is how you do your job, by the way. Don't start with that sentence, all right? That's number one. The first thing would be, don't try to make them change their languages and tools. I had this conversation inside Microsoft at some point to say, what are our DevOps kind of tooling for doing machine learning? Like, if somebody wants to connect into our services in Azure, how do they do that? How do they write their machine learn stuff and get it embedded in our things? And they say, oh, well, first, we've got this really good plugin for Visual Studio. I'm like, nope. Data scientists are not using Visual Studio, sorry. Like, you can't tell them the way you do this stuff properly is to not use the stuff you're used to at all, right? So you need to respect the languages and the tools that the data scientists are already using. Don't make them change that. Experimentation is also a really big part of data science. You could look at the data, try to run some models over it and see whether it behaves the way you think, and then not get a very good result out of it and scrap that experiment at all. I kind of like to think of this as kind of extreme spiking. If you're familiar with spiking, where you're like, I haven't used this component before, I haven't used this library before, I'm just going to create a new project, have a hack at it, see if it's going to work for me. Great. It seems to after a few hours of hacking. Let's throw that away and let's put it in our actual application. This is something that happens constantly in machine learning in particular. There'll be an effort to train a model based on certain hyperparameters and certain algorithms and things like that, based on what the data scientist thinks is likely to work. They run that experiment, turns out it's terrible. That just didn't work. All right, well, we need to save the results of that experiment so nobody repeats my mistake, and then scrap it and move on. Right? So we need to respect that kind of process as well. Life cycles are very different across data science projects as well. We try to, as much as possible in software development, think about products rather than projects. So the traditional waterfall way of, well, you have this set of requirements and then in 2 years we're going to come back and ask you to put it in production. We don't like doing that anymore, right? I worked at the last consultancy company I worked for. Day one, we would put something in production. And then after that, it's just small iterations. We build on that hello world so that we are continually iterating. If you have a data science process or a data science project which is to produce a Word document at the end of every year, there's no point having a life cycle that is continuously deploying this Word document, right? So you've got to respect the life cycle that belongs to that data science project as well. And then finally, there's a really important part of data science at the moment, especially when it comes to deep learning and deep neural networks, around traceability and explainability of what this model is telling you. And this is a really hard one. Right? If you have a deep neural network where you feed it some information and it gives you an answer at the other end, most of the time you cannot explain how it got that answer. Right? That can be extremely problematic in some fields. Right? Especially, imagine if you have a predictive model that tells you whether somebody is going to default on their loan or likely to default on their loan, therefore are you going to lend them the money or not? You feed in all the information, the result comes out and it says, no, do not give this person the money. They'll come to you and say, well, why didn't you lend me the money? You can't say, the computer said no, right? You can't say that, and especially when it comes to heavily regulated fields and things like that. Think about automatic driving cars and things like that. Why did you hit that pedestrian? You know, we're not really sure. There's a deep neural network that's just telling us not to do that, or told us to turn right. Okay, you can't do that. So traceability and explainability is something that you really need to be aware of when you're building this process as well. Can you explain what you've done, and can you trace it all the way through to an answer? All right, so those are some things to care about. The number one thing I hear when somebody hears DevOps for data science is, oh, you're telling me how to put my predictive model into a Docker container, right? That can be useful, right? I'm not discounting that, but it is not just about operationalizing your model, right? And I have this conversation internally too. I say, oh yeah, I'm focusing a lot on DevOps for data science at the moment. And they're like, oh yeah, we can put the models in Docker containers. Like, cool, but that's not what I'm talking about, all right? So it's not just about operationalization of your data science predictive models. It took me a while to work out how to say that word, by the way, operationalization. So I'm pretty proud of that. It's also about a lot of other things. I'm just going to run through a few ideas with you, things that we know in software development that can apply to data science process. Number one, source control. You would be very surprised how few data science projects have any kind of source control involved. There are Python scripts that just live on somebody's machine, and it's just a mess of these things, and there's data somewhere, and they use that data to produce a model, and then here's the model, and they hand it over to a developer if that's what happens, or they run the data that they've been told to get answers for through that model, and they give them the answers, and the code lives nowhere. Like it's on that person's machine until they accidentally deleted it, right? Source control is not often a thing because quite often data science projects are done by one person at a time, right? Very much like the good old days of software development where the code you wrote didn't need to be in source control because nobody else worked on it. It was your code, right? So source control is really, really important. The question comes, what do you put in source control? Like Python scripts to filter your data and process your data, of course. Like TensorFlow written in Python, fantastic, you should put that in there as well. Do you put all of your experiments in there? And do you put them in there maybe as different branches? And now we start to get into the tools and techniques, right? If you told the data scientist, oh, every time you do an experiment, just create a new Git branch, they don't use Git. Like, that's not going to work, right? As well as that, it's not just about the models, sorry, it's not just about the code that they've written to create these models, it's also the data that they ran that code over. So do you version the data? And I have had discussions with a lot of data scientists who are trying to work out how to put terabytes of data in source control because they're running the models over those terabytes of data and then they get new data, but they need to do new model runs. So they put that data in source control. It's not a great idea to put a terabyte of data in source control, right? It does not work very well. So source control is something you need to think about, but what do you put in there? And there is unfortunately very little tooling around versioning of data at the moment. That's a problem that we're trying to get our heads around. But source control for this is what the code looked like at the time, and this is the model that we have so we can share it amongst our team, or the code that we have so we can share it between our team, is something that you need to think about. All right. One thing as well that I like talking about is refactoring. So if you're in an organization that deploys every 6 months, for example, and somebody told you, go in and make some changes, and so like, because starting in a week, we're going to deploy that 25 times a day. You just can't do that in so many cases. Like, you can't just suddenly deploy this thing 25 times a day because it's just not supporting that. Like, the architecture of your application does not support being deployed constantly, right? You may need to make some architectural changes to your application to enable you to deploy continuously. The same thing happens with data science. If you are trying to run this model every time, but it takes you like hours and hours to filter that data and summarize the data into a form that your model can run over or that your code can run over, you can't do it on a continuous basis because that data is not in the right shape for what you need. So maybe you need to refactor your data strategy. Maybe you need to have a pub-sub model like we saw earlier in the week, where the stuff that you're using for your machine learning is just pulling the data it needs from a subscription, but the data is stored in a particular way somewhere else. Maybe you need to completely change the way you store your data, especially when it comes to traceability and explainability. If you create a model, and that model is a predictive model that gives you certain answers, and somebody says, we need to know what data led to that model, but you have a database that is mutable. That data's gone now. Do you have like backups for every minute that that thing was created? And maybe you don't. So maybe you actually, if you need that traceability, maybe you need to change the way you store your data so it's not update only, but create only. So you have a single record, and if you need to change that record, you don't change it, you just mark it as deleted and you create a new one. So maybe there's some refactoring that needs to happen with your data strategy as well. Infrastructure as code is something that's really familiar to DevOps as well. We tend to think about it as the deployment environments, like the environment we deploy to. I think this can extend to the data science environments as well. What versions of what applications are on these gigantic machines that you need to do your machine learning. If you can standardize that in code, that means every data scientist in your team is using the same gigantic machines in the cloud to process these terabytes of data. That can be really, really powerful for this as well. I've spoken to a lot of data scientists who have this exact problem. Somebody trains their model on a machine that they've built up, and then the model goes out and it works in production, and somebody else tries to recreate it, and it just does not work for them. The model that they get when they run the exact same process is completely different because the machine was different. The versions of the libraries were different. It wasn't as powerful. It didn't have enough memory to actually process it in that way. So having a standardized processing environment is really important as well. And you can do that with techniques like infrastructure as code. Automation kind of goes without saying. If you have this cycle where it's continually deployed to production and you need to monitor it and things like that. So think recommendation engines. That's a really good example. Automating the update of a recommendation engine based on new data that's constantly coming in. If you have a process where it retrains the model based on new data and then pushes that all the way through your test environment out to production without somebody having to do it manually, that's something we've been doing in software development for a while. So automating that process is something that is probably not familiar to data scientists in a lot of cases. If you're worried about automation as well, I love this XKCD comment because there's an XKCD comic for everything. There's a really good graph of how long you should spend on a task to automate it. So for example, if it saves you 5 minutes, this automation saves you 5 minutes, and you do it daily, you can spend 6 days automating that task and you'll get your time back in 5 years. Right? So like you can actually just give somebody that table if they want to know whether you should automate something or not. That's science. He does science with comics. So automating this stuff, if it's continuous, is really valuable. But if you look at, if it saves you a second and you do it once a year, you're only going to get your money back after 5 years if you spend 5 seconds automating that task, right? So this comes into the cycle of that data science project as well. And of course, the one that we all think about with DevOps, the ideas of continuous integration, continuous testing, to continuous delivery. These can be really important for those cyclical development of machine learning models as well. Testing is a tricky one. How do you test that a model is giving you the expected predictions? That can be a difficult decision. I am very firmly of the idea that you should test in production when it comes to predictive models. And you test in production by doing things like, when we deploy this machine learning predictive model out to 2% of our fleet, or we deploy it out to a small percentage of our users, do those users follow the path that we want them to follow through our application more effectively or less effectively? Rather than saying, are my recommendations better? Is how do you judge that? You judge whether people are using it the way that you want them to use it. So having those funnels. But testing that can only really happen in production. You can't really test whether your users are going to use it the way you want in your QA environment. So that's really useful as well. And continuous integration, continuous delivery really come into that automation and pipeline stuff that we're all pretty familiar with. The last one, and that kind of ties into testing in production, is production monitoring. Right? Not just are people using this, or are people actually getting value from the new model that I've put in production or the new predictions that are coming out of my model, but is it performing well enough? I mean, a recommendation engine is not very good if somebody has to wait 10 minutes for the website to come up with great recommendations. Right? We may have created a new predictive model that is too slow to use. So is that feasible in production? Is it happening in production? But as well as that, is stuff happening in production that we did not predict? Like we may have a log function in the middle of our deep learning model, and we never tested it by passing in something that results in 0 in that deep hidden layer, right? So does it explode in production? So you need to build that kind of monitoring into your production systems that use these models as well. And again, something we do in software development, something that is quite often not thought about in data science. All right, this is kind of your overwhelming aim, anything with DevOps as well, shift left. So in case you haven't heard it already this week, the idea of shift left is if you think about your process from idea all the way through to something happening in production or getting into production and monitoring what's happening in production as a pipeline from left to right, you want to move the discovery of problems and the work that you do as far left as possible. Somebody was saying in one of the open spaces before, for each kind of phase that your idea or that your code goes through, you're kind of looking at an order of magnitude more expensive to fix it if there's a problem. So the same thing kind of goes for your machine learning model. If you have something which takes a week to train, and you only find out that it breaks at the end of that week of training, then maybe you need to do some stuff further left to make sure that it's not going to fail. Train it on a smaller data set. Push all of that work as far to the left as possible. So this is your overwhelming idea. All right, I've got a few seconds left. So these resources, there's a slightly more expanded version of these slides, which is quite meta, of that URL. The team data science process, if you're interested in how that works, and it is a lot more detailed than just those 5 or 6 points that I gave you. have a look at that. There is also a video on Ignite about data science process, from Ignite, which is a conference that Microsoft runs, about the data science process and some of the tooling that we have. There's actually extensions for Visual Studio Code, which some data scientists do use, so we're not forcing them to use something they don't. And it's all API driven anyway, so feel free to have a look at that. And of course, I will be around for the rest of the day and in open spaces if you want to have a word. Thank you very much.